Hello everyone. Let's understand the concept of degrees of freedom which is required in chi-square tests. Okay. So let's say you have a contingency table. Okay. With let's take a small table with two rows and two columns. Okay. Now hypothetically assume that I know the total number of, let's say, when if you talk about the group and success example, I know the total number of people belonging to row 1 is 20 and total number of people belonging to row 2 is 35. That I know in advance. And I also know the number of people in column 1 and number of people in column 2. So let's say those are also 20 and 35, let's say. Okay. And I also know the total count, that is 55. I don't know exactly how many students belonging to row 1 also belong to column 1. I don't know the exact cell values. Okay. So all these are, let's say, question mark for me right now. Okay. Now, how many cells can I choose freely before the rest are determined automatically? So, for example, if I decide to put a number, okay, if I decide to put a number in this particular cell, if I decide to put the number 15 in this particular cell instead of question mark, I say it is 15 now. So, am I free to write any other number over here other than 5? The answer is no. So when I write the count 15 over here, this quantity is automatically fulfilled or completed or filled up. Okay. Similarly, the quantity over here is also filled up. There is no freedom, there is no other choice but to fill 5 over here. And once I have a 5 over here, do I have any other choice other than filling the value 30 over here? So effectively, I was free. I had the freedom of filling only one value over here, that is this particular value. And once I fill this value, given that I know all the row and column totals, once I fill the value in any one of the cells, all other cell values are automatically filled or calculated. There is no freedom. That one value dictates all other values, you can say. So therefore, I'll say that the number of degrees of freedom in this case is only one. Okay, so when you have a 2 by 2 contingency table, you have only 1 degree of freedom. Now let's go to a larger table. Let's go to a 3 by 3 table. Okay, so let's say we have, let's see, row 1, row 2, row 3, and we have column 1, column 2, and we have column 3. Again, we have some totals. So let's say the total along the row we know to be 50. Let's say total along row 2 we know to be 30, and let's say arbitrarily this is 20, making it a perfect 100. Okay, and let's say the total along column 1 is 40, total along column 2 is 35, total along column 3 is 25. So we know the totals, but we don't know the exact details of these 9 cells which are there in this table. Okay, grand total we also know, that is 100. Okay, so now let's again start with our hypothetical exercise. Basically, how many cells can you freely choose? Okay, so let's start with the first cell. Okay, so let's say the first cell, let me choose as, let's say, 10. Okay, now still I know that column 2 plus column 3 should be something which adds up to 50, and row 2 and row 3 should be something which adds up to 40. but still I have the freedom to choose the contents of column 2. Now let's say I choose the column 2, that is row 1, column 2, to be 20. I can do that. But now, when I choose any arbitrary value over here, this is 10, this is 20, sum has to be 50. Therefore, what I can say is this has to be 20. Similarly, along the rows, I have some freedom over here. Okay. So let's say I say that this is 15. Let's again go to column 2. Um, and let's say I choose the value 10 over here. Again, I have no freedom over here but to choose 5. Okay. Now, do I have a freedom to choose any value over here? No, because I know that total number of people belonging to the column 1 event, or total number of um, things, or total of column 1 is 40. Total of column 1 has to be 40, and I already have 10 plus 15, which is 25. So this has to be 15. So I have no freedom in choosing this. Similarly, this has to be 5. I have no freedom in choosing this. And again, this element has to be 0. I have no freedom in choosing this. That means, how many elements could I choose freely in this case? I could choose 4 elements freely in this table. So I can say that I have 4 degrees of freedom. Now, if you observe the trend in general, I can always make a choice for C minus 1 columns in R minus 1 rows. So, in general, that gives us the formula for calculating the degree of freedom for any arbitrary contingency table. It can be a rectangular table, number of rows not equal to number of columns, or whatever. In general, degrees of freedom is equal to number of rows minus 1, total number of rows minus 1, into total number of columns minus 1. Okay, this is number of rows minus 1 and number of columns minus 1. You multiply those things, that will give you the total number of degrees of freedom for any given contingency table.